Download this code from codegive.com, link in the description below. OK, let's dive into a comprehensive tutorial on building an edge gateway with Netflix's zuul, incorporating techniques inspired by Mikey Cohen's practices. We'll cover the core concepts, configuration, coding examples, and important considerations for production deployment. What is an edge gateway? An edge gateway, or API gateway, acts as the single entry point for all client requests into your microservices architecture. Instead of clients directly interacting with individual microservices, they communicate with the gateway, which then routes requests to the appropriate backend services. This provides several key benefits. Abstraction hides the complexity of the backend architecture from the client. Clients don't need to know how many services exist, their locations, or how to access them directly. Security centralized authentication and authorization can be implemented at the gateway, protecting backend services from unauthorized access. Rate limiting and throttling. The gateway can enforce rate limits to prevent abuse and ensure fair usage of backend services. Monitoring and logging. A single point for monitoring and logging requests, providing valuable insights into system performance and potential issues. Transformation. Requests and responses can be transformed at the gateway, example format conversions, header manipulation. Routing. Intelligent routing based on request paths, headers, or other criteria. Load balancing. Distributing traffic across multiple instances of backend services. Circuit breaker. Protecting the system from cascading failures by preventing requests to failing services. Why zuul? Netflix zuul is a battle-tested edge gateway that provides a powerful and flexible solution for handling these responsibilities. zuul is designed to be highly scalable, robust, and adaptable to changing requirements. It's written in Java and typically integrated into a Spring Boot application. Mikey Cohen and zuul best practices. Mikey Cohen, a former Netflix engineer, has shared valuable insights and best practices for using zuul effectively. Some key principles from his work include: filters. Utilize zuul filters for pre-routing, post-routing, and error handling logic. Dynamic routing. Configuration-driven routing rules that can be updated without restarting the gateway. Customizable error handling. Graceful handling of errors, including retries and fallback mechanisms. Monitoring and observability. Implementing metrics and logging to track gateway performance and identify issues. Resilience. Employing techniques like circuit breakers and bulkheads to prevent cascading failures. Asynchronous processing. Using asynchronous operations where possible to improve performance. Tutorial: Building a zuul edge gateway. Let's build a simple zuul edge gateway step by step. 1. Project setup, Spring Boot. Use Spring Initializr, start.spring.io, to create a new Spring Boot project with the following dependencies. Spring Web. Spring Cloud Gateway, or Spring Cloud Netflix zuul for zuul 1, but zuul 2 is now preferred. Eureka Discovery Client, optional, for service discovery. Actuator, for monitoring. Project structure. 2. Enable zuul. In your zuul gateway application.java, the main Spring Boot application class, add the @enable zuul proxy annotation. If you are using Spring Cloud Gateway, this is not needed. Instead, use @enable discovery client. 3. Configuration, application.yml. Configure zuul routing rules, service discovery, and other settings in your application.yml, or application.properties, file. *eureka.client.service URL.default zone, the address of your Eureka service registry. This is how zuul, or Spring Cloud Gateway, discovers the locations of your microservices. If you're not using service discovery, you can comment out this section and use URL to hardcode the backend service URL, not recommended for production. *zuul.routes, zuul1, or spring.cloud.gateway.routes, Spring Cloud Gateway, defines the routing rules. *path, the URL pattern that zuul should match for incoming requests. / means match any path under /my service. *service ID, the logical name of the backend service in Eureka. zuul will use Eureka to find the actual IP addresses and ports of the service instances. *URI, used in Spring Cloud Gateway. // indicates load balancing via service discovery. * predicates, define the conditions for matching a route in Spring Cloud Gateway. 4. Create zuul filters. Zuul filters allow you to intercept and modify requests and responses as they flow through the gateway. Common filter types include *pre, executed before the request is routed to the backend service, example authentication, logging, request modification. *route, the actual routing logic, usually handled automatically by zuul based on the configuration. *post, executed after the backend service has responded, example response modification, logging. *error, executed if an error occurs during the request processing. Create the following filter classes. Prefilter.java, postfilter.java, errorfilter.java. *filter type, defines the type of the filter, pre, root, post, error. *filter order, determines the order in which filters of the same type are executed. Lower numbers execute first. *should filter, a boolean that determines whether the filter should be executed for the current request. *run, contains the actual filter logic. The request context object provides access to the request, response, and other contextual information. 5. Fallback handling, resilience. Implement fallback handling to provide a graceful response when a backend service is unavailable. This is crucial for building resilient systems. myfallbackprovider.java. *getroute, specifies the service ID for which this fallback provider should be applied. * means it will be applied to all routes. You can set it to a specific service ID if you want to define different fallbacks for different services. *fallback response, creates the fallback response that will be returned to the client when the backend service is unavailable. You can customize the status code, headers, and response body. 6. Running the gateway and a backend service. 1 Eureka server, optional if you're using service discovery, start a Eureka server. You can create a simple Spring Boot application with the @enable Eureka server annotation. The default port for Eureka is 8761. 2 Backend service * create a simple Spring Boot application that simulates your microservice. Register this service with Eureka, if using service discovery. Make sure the spring.application.name in the backend services application.yml matches the service ID you configured in your zuul routes. 3 Zuul gateway * run your zuul gateway application. 4 Test * send a request to the zuul gateway on port 8080, using the path you configured in your route, example http://localhost 8080/myservice/api/data. The gateway should route the request to your backend service. If the backend is down, you should see the fallback response. Important considerations and best practices, Mikey Cohen inspired. Asynchronous filters. Use asynchronous processing in your filters where possible to avoid blocking the request processing pipeline. Zuul 2 supports asynchronous filters natively. Bulkhead pattern. Implement bulkheads to isolate failures and prevent them from spreading to other parts of the system. A bulkhead limits the number of concurrent requests to a specific service. Libraries like Resilience4j can help with this. Circuit breaker pattern. Use circuit breakers to automatically stop sending requests to a failing service for a period of time. This gives the service time to recover and prevents cascading failures. Hystrix, deprecated, and Resilience4j are popular options. Spring Cloud Circuit Breaker provides an abstraction over different circuit breaker implementations. Rate limiting. Protect your backend services by implementing rate limiting at the gateway. This prevents clients from making too many requests in a short period of time. Libraries like Spring Cloud Rate Limiter can be used. Dynamic configuration. Use a configuration server, example Spring Cloud Config, to store your zuul routes and filter configurations. This allows you to update the routing rules and filter logic without restarting the gateway. Centralized logging. Use a centralized logging system, example Elk Stack, Splunk, to collect and analyze logs from your gateway and backend services. This makes it easier to troubleshoot issues and monitor system performance. Include request IDs in your logs to trace requests across multiple services. Metrics and monitoring. Collect metrics from your gateway, example request latency, error rates, and monitor them using a monitoring system, example Prometheus, Grafana. Spring Boot Actuator provides built-in metrics. Security. Implement authentication and authorization at the gateway to protect your backend services. Use HTTPS to encrypt traffic between the client and the gateway. Validate all input to prevent injection attacks. Regularly update your dependencies to address security vulnerabilities. Testing. Write unit tests for your zuul filters and integration tests to verify that the gateway is routing requests correctly and handling errors gracefully. Load testing. Perform load testing to ensure that your gateway can handle the expected traffic volume. Identify bottlenecks and optimize performance. Code example, Spring Cloud Gateway Rate Limiter. Here's an example of using Spring Cloud Gateway's rate limiter. Request rate limiter adds a rate limiter filter. The parameters are replenish rate, the rate at which tokens are added to the bucket, per second. Burst capacity, the maximum number of tokens the bucket can hold. Requested tokens, the number of tokens that is being requested. Key resolver, the strategy for resolving the key to rate limit by. This could be user ID, IP address, etc. Zuul 1 versus Zuul 2 versus Spring Cloud Gateway. Zuul 1 * the original Zuul. Mature and well established. However, it's synchronous and relies on the Surflay API, which can limit performance in high traffic scenarios. Hystrix, a dependency, is now deprecated. Zuul 2 * a rewrite of Zuul with asynchronous, non-blocking I/O. More performant and scalable than Zuul 1. It also integrates better with reactive programming models. Still uses Netty, which may require more config. Spring Cloud Gateway * Spring's official gateway solution. Built on Spring Web Flux, it's fully reactive and non-blocking. provides a modern, flexible, and well-integrated solution for building edge gateways within the Spring ecosystem. It's generally the preferred choice for new Spring Boot projects. Choosing the right option. For new Spring Boot projects, Spring Cloud Gateway is generally the best choice. It's the most modern, performant, and well-integrated option. If you have an existing Zuul 1 application, consider migrating to Spring Cloud Gateway or Zuul 2 if you need better performance or scalability. Conclusion. Building an edge gateway with Zuul, or Spring Cloud Gateway, is a crucial step in architecting a microservices-based application. By following the best practices outlined in this tutorial, inspired by Mikey Cohen's insights, you can create a robust, scalable, and secure gateway that effectively manages traffic, protects your backend services, and provides a better experience for your clients. Remember to prioritize resilience, monitoring, and dynamic configuration to adapt to the ever-changing demands of a production environment. Choose the appropriate Zuul or Spring Cloud Gateway version according to your needs and the overall architecture of your application. Good luck.